Welcome again, students, for the second half of our lecture for introduction to the pneumatics. The learning outcome in this hub are listed here. Just have a look on it. Learning outcome: first, we'll define the term pneumatics. Then we'll explain how power can be transmitted through compressed air medium. Third, understand terms pressure and its units. Then specify the economical pressure in pneumatics. Then we'll differentiate between free air and normal air. We'll identify the adverse effect and contaminants in pneumatic system. We'll list key pneumatic applications. Then we will discuss the advantage and disadvantage of pneumatic system. And at last, we'll have a look on importance of standardization in pneumatic system. Now we will define a term pneumatics. Pneumatics derived from pneuma, a Greek word, the meaning of which is wind or breath, and plus atics, which is a study on or study for. The study of pneumatics deals with a system operated with air or other gaseous media to impart power or to control power. The term pneumatics is derived from the Greek word pneuma, meaning wind or breath. Hence, pneumatics may be defined as the study of movement of air. Pneumatic power is the power that is transmitted by pressurized air or moved air. It may be used to power machines or to control or regulate machine. Now we'll be discussing compressed air for transmitting power. You can see three blocks: compressor, control valve, and actuator. This was the very simple or very basic pneumatic system here. Right. The pneumatic medium usually employed for transmitting power is the highly compressible air. Since gaseous substances are compressible in the ratios of decrease in volume to increase in pressure, a compressor is used as an energy source here. The compressed air is then prepared or treated in several stages, which is so called as a conditioning of air, or you can say processing of air, to remove undesirable contaminants present in it and stored in a tank called receiver tank. Then after it is stored at receiver tank after conditioning. The other issues of concern at this stage are the distribution of compressed air, regulation of pressure, and introduction of fine mist of lubricating oil in the compressed air, which is desirable. That we will see afterwards why it is being done. The compressed air medium is subsequently used to do work in a controlled manner by allowing it to expand back to the atmospheric pressure. The work done in this expansion is transmitted to a load surface such as piston or vane, which will be moved by the expanding air with a force equal to the product of the air pressure acting on the piston and area of the piston. The very basic equation, that is force is equal to pressure into area. So if you want to define a function of pneumatic system in a very easy manner or very in a simplified manner, it is like applying a force to a gaseous fluid like air and transmitting pneumatic pressure all through the fluid, and then converting the stored energy back into the mechanical force before work could be done. Now we will be discussing our next point, that is understanding term pressure and its units. Before understanding pressure, how pressure is defined, for that you should know the Pascal's law. What Pascal's law suggests that? It is a two-part statement. The first statement is pressure at any point in a static fluid is the same in every direction. I am repeating again. Pressure at any point in a static point is the same in every direction. And the second part of the Pascal's law is that pressure exerted on a confined fluid is transmitted equally in all directions. The second part says that pressure exerted on a confined fluid is transmitted equally in all directions, acting with the equal force on equal areas. So this law is at the heart of all fluid power applications and contributes as the basics for all calculation and prediction. Now how we define air pressure? That is P is equal to force per unit area, right? We take P, pressure in Pascal, force in Newton, let's say A, area in meter square. This is a bracket, meter square. So 1 Pascal will be 1 Newton per meter square, and the 1 bar is equal to 100 kPa or 10 raised to 5 Pascal. The other units are 1 kilogram force per centimeter square, which is equal to 0.981 bar. 1 bar is equal to 1.02 kgf per centimeter square. Then 1 bar is equal to 14.5 psi. 1 atmosphere is equal to 1.013 bar. Now we'll be discussing next point is economical pressure in pneumatics. Means what should be the economical pressure we should be kept for a pneumatic power system. So pneumatic system have been developed as a low pressure system, right? Kindly note this, it is a low pressure system. So pneumatic system have been developed as a low pressure system in a comparison to hydraulic power system, with hydraulic power system which operates more than 150 bar. So pneumatic air conditioning devices such as valves and cylinders are designed for a maximum operating pressure of 8 to 10 bar only. However, practical experience has shown that 6 bar is the ideal pressure for the economical operation of pneumatic system. This pressure allows, what it says that if you keep pressure near to 6 bar or 6 bar, anything nearer to 6 bar, 8 bar, right, we will get this advantage, right? Compressors to be relatively simpler and cheaper we can have while working with this pressure 6 bar. Then installation cost of pipe system to be kept minimum. Then valves and cylinder to be kept to reasonable dimension, minimum wear and maximum efficiency. So all these 4 points, what it says that if you go for a higher pressure, then the compressor will be costly and complicated also. It needs staging also. Then the piping cost will be higher, and you will need to have a high gauge pipe, and the cost will be also high and the complexity will be high. Then valves and cylinder for high pressure, they are again quite costlier and very difficult to handle also. So for having a minimum wear and maximum efficiency, for a pneumatic power system we generally works nearly on a 6 bar. Now we'll try to understand or differentiate these two terms. One is a free air and the another one is a normal air. While we are studying pneumatics, so in pneumatics the existence of the following two conditions of atmospheric air is well accepted. First one is air at the atmospheric condition at the point where the compressor is located. So air at the atmospheric condition at the point where the compressor is located is defined as a free air. The term does not mean air under identical conditions because altitude, pressure and temperature are different at different location and at different times. So free air will therefore vary with atmospheric condition. And the second term is a normal air, a more standard term for the condition of air at given location or time is the normal air. This is defined as the air at sea level, that is atmospheric pressure of 1.01325 bar, conforming to the Indian Standard Organization, that is ISO R554, and the temperature of 20 degrees centigrade and relative humidity of 36%. The condition of normal atmosphere are employed as a basis for deriving average value for compressor delivering volume, efficiency and operating characteristic. Next we will discuss the effect of contaminants. So contaminants in atmospheric air. So atmospheric air is a mixture of nitrogen, oxygen, traces of inert gases, then water vapor and impurities such as dust, soot and other particles or particulates. Depending on the humidity, air may hold up to 4% water vapor at any one time and place. In industrial surrounding, air carries several harmful dust particles and or oil particles. Industrial dust includes iron, carbon, silicate, fiberglass, and abrasive materials of all kinds. Particle size is measured in micrometers or microns, we can say. Then dust particles are usually larger than 10 micrometer or micron, whereas oil particles are usually in the order of 1 micrometer. These particles must be prevented from entering a pneumatic system, otherwise they will damage compressor seals and disturbs the operation of downstream components such as regulators. So what are the effects? We have adverse effect of contaminants. This is the damage to compressor seal. Second, disturb the operation of downstream components. Which are those? This is the regulators, valves, and cylinders. Moisture is present in air in the form of invisible vapor, that is superheated steam, which is so called as the moisture in the vapor form is difficult to remove from air as it is in the suspended form. The maximum amount of moisture that can be absorbed by a given amount of air at a particular temperature is called saturation quantity. It is a function of temperature and it is given by the dew point chart. The dew point temperature is the temperature at which air gets saturated with water vapor. As can be seen, there are charts are available. So while you are looking to the charts, you can see that air with 17.4 gram of water vapor per cubic meter, right? A dew point temperature of 20 degrees centigrade. The ability of a given volume of air to absorb moisture increase with increase in temperature, that we can conclude from that moisture chart also. Dew point chart, we can say it is. This is a sample of dew point chart, where here that is 20, or here 20. We can draw this graph like this. This shows the gram Newton meter cube here, and this side it shows temperature in degree centigrade. Now further we will be discussing the advantage of compressed air system. So you can list down the advantage of compressed air system, that quantity. So air is available everywhere in unlimited quantity. So quantity wise, compressed air system, it is advantageous. If we talk about power transmission, compressed air can be easily transmitted through pipes over long distance. So this is advantage. If you talk about advantage on the basis of storage, so huge quantity of compressed air can be easily stored in a receiver tank. This is the stored potential energy. The system can receive the compressed air directly from the tank, and the compressor need not be in operation always. Then if you talk about speed and acceleration, then compressed air is a fast working medium. The range of operating speed of pneumatic cylinder is 1 to 2 meter per second. So it is having a high speed and acceleration. Air is extremely compressible and elastic and is capable of absorbing large amount of potential energy. This property makes possible the use of compressed air to obtain smooth acceleration and deceleration of actuator, and reversal of direction of motion with relative freedom of shock. That is also possible while you are using compressed air. If we talk about the control, then actuator speed in compressed air system can easily be controlled by the simple use of valves. There are different types of valves available. We will discuss that afterwards in other chapter. Because force can be easily controlled, mechanical elements driven by compressed air system can be stalled for infinite period without any damage. A compressed air system can quickly and efficiently be controlled with a few control elements and can readily be adapted for automation. If we talk about advantage for overload, so compressed air tools and working elements can be subjected to loads even at standstill and are therefore overload safe. So we can provide safety for overloading also, so there is no issue or there is no harm. So it is an advantage. And few general advantages, like one, a compressed air system is simple method of transmitting energy. The use of compressed air system may allow simplification of machine design and it is easy to install and maintain. Components of air systems are usually very compact, light in weight and can be easily serviced. Maintenance. There are fewer mechanical parts in compressed air system and hence these are more efficient and more dependable as there is less mechanical parts. Air may be exhausted to atmosphere without any harm, so return lines are not required like we need in a hydraulic system. Here there is no need of return valve or return lines. Air equipment is not normally subjected to sudden failures. Compressed air systems may be used in hazardous areas where electrical control cannot be used. So these are the few advantages of compressed air system. Like advantages, there are certain disadvantages of compressed air system also. Like first is the all compressed air systems are vulnerable to damage by dirt or contaminations. So the basic enemy of any compressed air system is a dirt, dust and contaminations. Hence compressed air required good preparation to remove dirt and moisture present in it. That is a essential task to be carried out to remove dust from the compressed air. Second, the compressed air actuators are only economical up to a certain force requirement. As I said earlier, it gives best result at 6 bar only. You can go up to 8 to 10 bars, but 6 bar it is a highly, you can say, optimized number. So based on the normal operating pressure of 6 bar, the limit is approximately 48 kilonewton. So the force limitation is 48 kilonewton, or you can say 50 kilonewton, 50 kilonewton. That much force you can transmit or apply with the help of compressed air system. Then comes the uniform speed. It is not possible to achieve uniform and constant piston speed with compressed air. Compressibility and elasticity of air can impair operation if these characteristics are not properly understood and used. So basically what I want to tell you that more skill is required for control of compressed air, right? If you haven't understood the characteristic of air or operating system of compressed air, then it will not give you a smooth or uniform operation or uniform or constant piston speed. Then comes the cost. Compressed air is a relatively expensive energy medium. The high cost of energy are compensated by inexpensive components and high performance. Then exhaust air is noisy, it gives noise. So nowadays this problem has been solved with the availability of efficient or effective silencers, or you can say muffler. Next is the application of pneumatic system. Pneumatic systems have been in use within the industrial process since the Second World War, that is 1945 nearby, and as such have set up a strong presence in modern industry. Continuous research and development of pneumatic power technology has significantly expanded and augmented its application to many areas. So we can list down few or outline application of pneumatic systems. One is in aircraft manufacturers, they use pneumatic system. Then cement plants, chemical plants, then coal mines, cotton mills, dairies, distilleries, then forging shops, foundry, machine tool manufacturers, material conveying, metal forming, oil refineries, paper mills, printing, space exploration, steel mills, and vehicle manufacturing. All these are the promising area where you can use uh, pneumatic system. An air equipment presents no sparks in explosive atmosphere, therefore it can be utilized in oil refineries, chemical plants and other plants that have the problem of explosive atmosphere. Air equipment can be employed under wet and humid conditions because there is no electric shock hazard. So the ever increasing number of pneumatic applications is due to research investments by the component manufacturer and the effort of creative people who design and develop flexible and efficient pneumatics control system. And why it is nowadays more use is just due to the development of symbols and standards that have become widely accepted and used throughout the manufacturing and processing industries all over the world. Now little bit of or you can say glimpse on standards. In engineering, standardization is very important, and again pneumatic system and hydraulic system is not it also needs some standardization. So in the early stages of development of industrial pneumatics, the inevitability for standardization was quickly recognized due to the use of inconsistent and often company specific terminology. The effort for a uniform definition and standardization of pneumatic components were initiated by some German organizations like VDI and VDMA. This led to DIN, that is Duchess Index Number, and then CTOP, and later on DIN ISO standards. So we will be talking about this first, that is ISO 12191 2006. It is a fluid power system and components, graphic symbols and circuit diagrams, which you will learn in this course also. That is part 1. Graphical symbols for conventional use and data processing application. This standard reflects ISO 12191 1991, that is 2006 is the second amendment in it. The second is ISO 12192 1995. So fluid power system and components, graphic symbol and circuit diagrams, part 2, circuit diagrams. This standard established for the rules for drawing diagram of fluid power system using symbols from ISO. Then comes ISO 5599. ISO 5599, it is port marking of pneumatic direction control valve. So how we are marking the port, 3 port, 2 port, or how to show it, that you can get from ISO 5599, and according to we have to draw. Then ISO 6432, it is a mounting dimension of pneumatic cylinders up to 8 to 25 mm only, right? This is up to 8 to 25 mm, and anything above that you will get it from ISO 6431. So ISO 6431 is a mounting dimension of pneumatic cylinder for 32 to 320 mm or more than that. Then comes CETOP RP 41. So it is a hydraulic and pneumatic system circuit diagrams. This stands for identification code for ports and operators of pneumatic control valve and other components. And this ISO 8573 is a quality classes of compressed air for general use. Now what is CETOP? CETOP is a Committee European this transmission all hydraulics pneumatics, is a federation of European manufacturer which is involved in 1962 in the standardization of pneumatics and hydraulic component in cooperation with the user of this product. CETOP recommends with the number RP, that where P are included in national and international standardization work. Then comes DIN, that is I said that is a Duchess Institute for Normung or Duchess Index Number. DIN, it is a German standard. Then comes a VDI, that is Verein Deutscher Ingenieurs, that is Association of German Engineers. Like Association of Mechanical Engineers, there are Association of German Engineers is there. Then VDMA, it is a Association of Mechanical Engineers in Germany, that is VDMA. So in this lecture we have gone through this, define the term pneumatics, then explain how power can be transmitted through compressed air medium, then understand term pressure and its units, then specify the economical pressure in pneumatics, differentiate between free air and normal air, then identify the adverse effect of contaminants in system, Then comes the least key pneumatic applications also, and we have also discussed the advantage and disadvantage of pneumatics. And at last we have seen few standardization or standards also. Next time we will start with the pneumatic systems in a bit detail. Thank you.